Alright, welcome back to the NUPOC video study guide for number 25. We're going to look at question 21 again in the general math section of guide 1. For those of you who watched the last video, we're going to take a look at the cross product and the dot product, but we sort of ran out of time, so we're going to do the dot product here in this video. So the dot product, unlike the cross product, right, is just a scalar. It doesn't have any direction associated with it. So let's say we have some d, some number d, right? That's equal to, let's say, a vector A dot a vector B. And let's just say we're operating in an x hat, y hat, z hat rectangular coordinate system, right? So this is just going to be ax times bx plus ay by plus az bz, right? So that's simple enough, and we just get some number. But let's go over a couple of properties of the dot products that can make it a little bit easier to get a quick grasp on what's going on and what d could be and all these things without having to do out this math every time. So the dot product really is the projection of one vector onto another. So let's think about it that way. So if we had some vector b, right, and then some vector a, like this, right? So if we said that d was a dot b, right, we would just say that, well, that's the projection. D is going to be the projection of a on b. So literally, if we had like some sort of spotlight here shining down on these vectors and say these vectors were, you know, some solid material or something, we would see that A would drop this shadow on B, right? And so that would be D. Okay? And so this is a great way to understand how, you know, the dot product is 0 when the vectors are perpendicular, and 1 when they're parallel. So let's think about it this way. If I had a situation where there was A, right, or sorry, let's say this is B, and then we had A right on top of it, right, and then I shine my light down on it, right, well, A's projection on B, right, I mean it's going to be 1, right? Well, it's going to be 1 times the magnitude of A and B, right? So let's write that out here. The D, the magnitude of D, doesn't really matter whether we say magnitude or just D because it's just a scalar, right? Is magnitude A, magnitude B, excuse me, cosine theta, or this is, you know, theta, this is the angle between them, okay? So what I'm talking about is when I say this is 1, I'm saying that this is 1 right here. So it's just magnitude A, magnitude B, okay? And so again, so we can say that D is at a maximum. So this is D is maximum, right? Here D is somewhere in between the minimum and the maximum. And here, right, if this was B and this was A, and we took our spotlight, right, and shined it down, there would be A would cast no shadow on B, right? So there's no projection of A onto B. Another way to think about it is this is 90 degrees, so cosine of theta, right, is 0. But I like the physical projection analogy. Makes it really intuitive. And so here we would say D is minimum, or really it's 0. So that's just a quick review, quick discussion on the dot product. Unlike the cross product, it's just a scalar value, and a really great way to think about it is the projection of one vector onto another. At least that's a way to get a quick handle on what you expect the answer to be, whether you expect it to be large or small or 0 or maximum, without having to do out all of the math every time. Another quick note, compared to the cross product. The cross product, when you take it, the order of the cross multiplication matters. So if I have A cross B, that does not equal B cross A. In fact, the magnitude will be the same, but it'll be 180 degrees out of phase. So if it's coming out of the paper, if A cross B is coming out of the paper, B cross A will be going into the paper. Whereas with the dot product, the order doesn't matter at all. A dot B equals B dot A. So it's just a quick overview and some key points, and I think this, I don't know about you, but I think this is a great way to visualize the dot product. Really very intuitive.